Welcome back. Don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuitions. Also, don't forget to follow the Facebook page, Mr. Rafa Online Tuition. A falling metal hammer is used to drive a hollow steel post into the ground as shown in the figure below. The hammer is lifted by an electric motor and it then falls freely to hit the basic plate. So we have, this is our lovely diagram. So we have rope from the motor to lift the hammer. So this is the metal hammer. This is the ground. Then this is the base plate. And this is the hollow steel post. Number 3A, Part A, state the energy conversions from the time the hammer is released from its highest position till after impact. After impact. So energy conversions. So remember that before the hammer begins to move, it was possessing potential energy. It was possessing potential energy. So potential energy. So this potential energy, as the hammer begins to move, it will be converted to kinetic energy. Remember the definitions of potential energy and the kinetic energy. Now, as the hammer hits the base plate, kinetic energy is converted to sound energy. It is converted to sound energy and heat energy. Okay, so before the hammer begins to move, it was possessing potential energy. As it begins to move, potential energy is converted to kinetic energy. As the metal hammer hits the base plate, it will make a sound. So meaning kinetic energy is converted to sound energy plus heat energy. Then altogether, what we are going to have is what we call mechanical energy. So sound plus heat energy. Then altogether, what we are going to have is mechanical energy. So now the base plate, as the base plate goes the ground, what we are going to have is mechanical energy. Mechanical energy. So what we are going to have is mechanical energy. So part B, the metal hammer has a mass of 1,500 kg and it is released from 3.2 meters above the base plate. Calculate the gravitational potential energy of the hammer. So gravitational potential energy of the hammer is equal to mass of the hammer times gravity times height. So mass I have, it is 1,500 kg. Gravity, it is constant, 10 newtons per kg. Then height is 3.2 meters. So potential energy is equal to mass is 1,500 times 10 times 3.2. So potential energy is equal to 1,500 times 10 times 3.2. So we are going to have 48,000 joules. 48,000 joules. So that is our potential energy. The speed of the hammer as it hits the base plate. So how do we calculate the speed? So now here we are going to use this formula of kinetic energy. So kinetic energy is 1/2 mass times velocity squared. So now we want speed, so which is velocity. So we want speed. So mass we have. Do we have kinetic energy? Remember energy conservation. Remember energy conservation. I hope you watched the previous video. So I hope you watched the previous video. So kinetic energy we have, okay, according to energy conservation. So we have kinetic energy is 48,000 is equal to 1/2 times mass is 1,500 times v squared. So there, the half of 1,500, that is 7,000. That's 750. So the half of 1,500 is 750. So now v squared, so over 750 over 750. So 750 goes, so we have v squared equals, so divided by 750, the answer is 64. So from there, mathematically, we are going to introduce the square root both sides for us to clear the squared. So v is equal to the square root of 64, that is 8 meters per second there. So that is velocity. So don't forget energy conservation. Don't forget to consider energy conservation. So where it says that energy cannot be destroyed, cannot be created, but it can only change from one form to the other. Part C, in raising the hammer, explain why the electric motor uses more energy than that is in B1. So what is in B1 is 48,000 joules. Now here they are saying that explain why the electric motor uses more energy than this one. So in this case, we can just assume that the electric motor, it has used 55,000 joules, but our calculation is 48,000 joules. So they are saying explain why the electric motor uses more energy than that we have calculated in B1. So example, so the reason is very simple, because more energy is needed to overcome friction. That's why the electric motor uses more energy than the one that we have calculated. Why? Because more energy is needed to overcome friction. More energy is needed to overcome friction. So that is the reason why more energy is needed. So D, assume the frictional force in the machinery is about 500 newtons. How much work is done to overcome this friction by lifting the armor to a height of 3.20 meters. So remember the formula for work done. Work done is equal to force times distance. So work done is equal to force is given 500 times height, which is distance, 3.20. So there we say 500 times 3.20. So the answer is 1,600 joules. Remember that work done is calculated in joules. Don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuition.